Good morning everyone. I am Arpita Agarwal, Assistant Professor in CSC Department in Akgec. So today we will be covering DSTL, BCS 303, which is in second year. And my target students are CSC, AIML and DS students. So today I will be covering Unit 5. Graphs and combinatorics. So this is one of the easiest unit and marks scoring unit. So today firstly we learn about graphs. So what a graph is? A collection of vertices and edges. A collection of vertices and edges is termed as graphs. Vertices is represented by V and edges is represented by E. Graph is represented by G. So we can say a collection of vertices and edges is a graph. So we are taking an example of it. This is a graph. So here it is a vertex, it is vertex, vertex and vertex. These are edges. So we can say this is a graph. So next we will study some basic terms for graph. So some basic term includes, number one is second is third is and fourth is order. So first one is incident edges. So number of edges incident on a vertex. Suppose we are having this graph. So edges incident on this is suppose E1, E2, E3 and 4. So number of edges incident on V1 is E1 and E4. If we consider V2, number of edges incident on V2 is E1 and E2. Number of vertices incident on V3 is E2 and E3. And number of edges incident on V4 is E4 and E3. So number of edges incident on the vertex is said to incident edges. So next comes the term adjacent vertices. We are taking again this graph as an example. So we can say V1 is adjacent to V2. V4 is adjacent to V1. V4 is adjacent to V3. So number of vertices connected with the edge are said to be as adjacent edges. Next, we have isolated vertex. Suppose we have two graphs. So, this graph is vertex V1, V2, V3 and V4, and this is V5. So, we can say this is an isolated vertex of this graph as it is not attached. So, next आता है finite and infinite graph. So, finite graph is a graph having fixed number of vertices and edges, and infinite graph is a graph does not having any fixed number of vertices and edges. So, order or size, number of vertices inserted is denoted as order. So, if we say, if we find the order of this, so if we find the order, we are taking the same example. So what is the order? Number of vertices in a graph is termed as order. So if we consider the order of this graph, the order of this graph is 4 because it is having a 4 vertices. Next, we have a degree. Number of edges incident on a vertex is termed as degree of a graph. Suppose if I have to find the degree of vertex V1, degree is denoted by D. So, a degree of vertex V1 will be 2 edges are incident on it. So, 2. So, if we consider the degree of vertex V2, then it is again 2 because 2 edges are incident on it. Suppose if we consider the degree of vertex V3, then again it is 2 because 2 edges are incident on E3. And if we consider the degree of vertex 4, again it is 2 because 2 edges are incident on it. We have next term as self loop and parallel edges. So, if we have this graph, so self loop, a loop that is starting from same vertex and ending in the same vertex. Suppose I am adding this is called the self loop. This is called the self loop. So, an edge starting from the same vertex and ending on the same vertex is termed as self loop. Next आता है parallel edges, or we can say is that multiple edges. So this is a parallel edges. A edge between the same pair of vertices are said to be as parallel edges. Our next term is undirected graph and directed graph. An undirected graph is a graph in which vertices and edges going out or incoming in that vertex has no edges attached to it. Has no edges attached to it. Then the graph is said to be as undirected graph. So, if we find the undirected graph so this is an undirected graph because edges has no direction attached to it. Next is directed graph. A graph having direction attached to edges are called directed graphs. Suppose we look this E1 edge, it is having a direction that it is outgoing from V2 and incoming to V1. So suppose if we look E5, so it is outgoing from V1 and incoming to V4. Suppose we look for E3, it is outgoing from V4 and incoming to V3. And suppose if we look for E2, it is outgoing from V3 and incoming to V2. So now you understood what is directed and undirected graph. So next we have in degree and out degree of a graph. So we are taking this example only. So if we say in degree of vertex V1, because vertex V1 has incoming edge E1. So in degree of vertex V1 is E1. Suppose we look for V2. V2 has no in degree because no edge, V2 has in degree E2. Because edge E2 is incoming. Now if we look for V3, V3 has in degree E4 because E4 is incoming edge. Suppose we look for V4, V4 has in degree E5 because E5 edge is incoming. Next we look, we have no other vertex. So in degrees are number of edges incoming in the vertex. Now if we go for out degree, if out degree of V1, what is going outside? So V1 has E5 edge as outgoing. Now if we look for vertex V2, V2 has E1 edge as outgoing. Now if we look for vertex V3, V3 has E2 edge as outgoing. Now if we look vertex V4, V4 has E3 edge as outgoing. So are you clear with the concept of in degree and out degree? In degree means edges coming inside the vertex, and out degree means edges going outside from the vertex. Next we are having types of graphs. So there are types of graphs also. Number first is simple graph. This is a simple graph. A graph having no self loop and parallel edges is a simple graph. Next is multi-graph. A graph having multiple edges. Multi-edges is a multi-graph. So next is pseudograph. Graph having self loop and as well as multiple edges are pseudographs. This is a pseudograph. So degree sequence is number of vertices and their degrees form the degree sequence of a graph. Now let us take another theorem, one theorem that is very important theorem for AKTU purpose, and 90% it comes every year in AKTU, that is hand shaking lemma. It can come, either problem statement will be given, either name will be given. So either the formula will be given, you have to prove this theorem. So statement of the theorem is, if graph graph says degree of vertex is twice the number of edges. Yes, we will see it by example. Suppose we have a graph. Its vertices are V1, V2, V3 and V4. So, and its edges are E1, E2, E3 and E4. So, suppose if we look vertex V1, this edge is contributing the degree to two vertex V2 and V1. Suppose we consider as edge E4, it is contributing to degree to V1 and V4. If we look for edge E3, then it is contributing to degree V3 and V4. And if we look for E2 edge, then it is contributing to degree V2 and V3. So each edge is contributing degrees to two vertex. So we can say that if we look the degree of V1, then its degree means number of edges attached to vertex. Then it is 2. Again we look for degree of V2, because two edges are contributing degree to V1, same as V2, same as V3 and same as V4. So we can say degree of a graph is equal to twice the number of edges. So in proof, how we write the proof for it? So we have looked at each edge is contributing the degree 2 times to a vertex. So when we are adding, each edge is contributing degree 2 times. So we can say that degree of vertex is twice the number of edges. So this is a very important theorem, and you should know this theorem. It can be asked from with the help of statement, either with the help of name. A statement can also be given, or this also be given, and you have to prove it. So thank you.